We have an arithmetic progression, and it is given that the sum to the m terms as given by Sm and the sum to the n terms as given by Sn. Also, it's given that the ratio of the sum to the mth term to that of the sum of the nth term is m squared over n squared. Then, using this information, we need to obtain the ratio of the mth and the nth term. So let's begin. So since our given sequence is an arithmetic progression, so we'll consider that the first term, we're going to consider the first term as a expressed in the lowercase, and the common difference d is will be expressed as d in lowercase as well. Using the fact that the sum to the nth term, so we know that the sum to the nth term of any general AP or arithmetic progression is given by n over 2 multiplied to 2a plus n minus 1 times the common difference d. So we can rewrite our ratio, which is given as Sm divided by Sn equals to m squared over n squared. So in place of Sm, we have m over 2 whole multiplied to 2a plus m minus 1 times the common difference d, divided by, we have the sum to the nth term, which will be n over 2 multiplied to 2a plus n minus 1 times the common difference d. So this is equals to m squared over n squared. So here we can cancel out 2 and 2. After cancellation, we are left with the ratio m over n on the left hand side, and we also have the ratio m over n on the right hand side. So both of them will get cancelled out, and this leaves us with 2a plus m minus 1 times d divided by 2a plus n minus 1 times the common difference d equals to m over n. Now what we'll do, we'll use a trick here. We will replace the value of m with 2m minus 1, and we're going to replace the value of n with 2n minus 1. So we will have 2a plus 2m minus 1 times d divided by 2a plus 2n minus 1 times d. So this will be equals to 2m minus 1 divided by 2n minus 1. So here we'll have 2a plus 2m minus 2 multiplied to d divided by 2a plus 2n minus 2 multiplied to d. This will be equals to 2m minus 1 divided by 2n minus 1. So if we factor out 2 from the two terms in the numerator, as well as 2 from the factoring out 2 from the two terms within the denominator, the other 2 will get cancelled out, and this is going to give us the final result, the a plus m minus 1 times d divided by a plus n minus 1 times d equals to 2m minus 1 divided by 2n minus 1. And this is nothing but the mth term. So this is our mth term divided by the nth term. So we have obtained that the ratio is 2m minus 1 over 2n minus 1. So this is what we were needed to show. Now coming to this trick. So how did I know that we have to replace it m with 2m minus 1 and n with 2n minus 1? So it boils down to the fact. So let's work around with this particular idea here. So we had 2a plus m minus 1 times d divided by 2a plus n minus 1 times d. So this was given by m over n. If we divide both numerator and the denominator with the number 2, so we have a plus m minus 1 over 2 times d divided by a plus n minus 1 over 2 times d. So this will be equals to m over n. Now our whole idea was to find out the ratio, the mth term to the nth term. So whenever we're trying to find out the mth term to the nth term, so if we use the general formula, this must be a plus m minus 1 times d divided by a plus n minus 1 times d. So in a sense, this expression m minus 1 over 2, this must be equals to m minus 1. This is going to give us m minus 1 equals to 2m minus 2. Now if we transpose this negative 1 to the right hand side and combine it with negative 2, then m becomes equals to 2m minus 1. So this is what we actually replace. So we replace the m value with 2m minus 1, and similarly if we take n minus 1 over 2 as equivalent n minus 2, so we will get n equals to 2n minus 1.